Hello, I'm David Seidman, and I work for Microsoft in the Microsoft Security Response Center. I manage a number of different programs, and among them is the Microsoft Vulnerability Research Program that I'm going to talk about today. I note that I like doing authentication better. I have a project that I'm working on now to replace passwords that you may have seen some things about, but we also have a number of initiatives that are happening through my group. My co-presenter, Jeremy Brown, was not able to make it today. He is the more technical person of our team and found the vulnerabilities that I'm going to discuss today. If I make mistakes in describing those vulnerabilities, it's his fault. What we're going to talk about today is what is Microsoft Vulnerability Research, because I imagine you probably have not heard of it, and how do we operate? What do we do, and where do things go wrong in that process? We'll talk through a few examples of vulnerabilities that we've found and reported through the program. There are 4 vulnerabilities listed in the slides, but we only are going to talk about 2 of them today. So if you're interested in the others, I can talk to you after the program. And we're going to talk about some things we've learned in this process, because it's been very interesting for us to switch from our traditional role as a vendor who takes reports and fixes them into a role where we report vulnerabilities to other third parties. We're not going to talk in great depth about how we handle vulnerabilities in our own products. We are going to talk a little bit about bug bounties, because I understand that's a topic that's interesting for this community. We're also not going to talk about any upcoming vulnerabilities. Everything we discussed today is something that has already been addressed. And we don't want to spend a lot of time discussing disclosure philosophies, full disclosure, coordinated disclosure. That's just not the purpose today. So what is Microsoft Vulnerability Research? Well, it's a program that started in 2008. It was founded by Katie Musaris, who many of you may know, and announced at Black Hat. And the program started because Microsoft was finding that many bugs we were aware of internally also affected third-party software. And we needed a way to help those third-party vendors address the vulnerabilities in their software so that they could make their customers more secure. This is distinct from the Microsoft Security Response Center, although it's part of the MSRC. And the MSRC handles problems with our own products. MSVR deals with problems in other people's products. And it's also not the same as Microsoft's bounty program. We'll talk more about bounties in a moment. At its core, MSVR is a program to help Microsoft employees report security vulnerabilities in third-party products. The purpose of this program is to help out our internal finders. So the program itself does not employ researchers. We work with the researchers who already work for Microsoft. And we provide some basic services. We take the annoying parts of reporting a vulnerability away from a researcher. So we handle tracking down contact information, storing a database of that contact information, and providing a lot of the go-between resources to find the right people and get the right things done. And we'll talk specifically about how that works. Our goal is to keep everyone on the same page. We don't want miscommunication. We don't want, some of our researchers are interesting people who may not work well with others. So we provide a go-between to help improve the relationship. And we are familiar with all the principles in play in the security ecosystem, whereas many of our internal employees are not. We also provide a platform to give credit to our researchers. So when a Microsoft researcher finds and reports a vulnerability, they receive credit, hopefully from the vendor, but they also receive credit from Microsoft. So there is a page, which is linked to here and will be available in the slides, where you can go see all of the vulnerabilities that our researchers have requested or have gotten fixed in third-party products. It's not quite all, because researchers do have the ability to remain anonymous. The reason why we're so interested in doing this is third-party code is very important to Windows. We run lots and lots of third-party software on our platform. In fact, third-party software is more commonly used to exploit Windows users than anything built into Windows or made by Microsoft. So this is very important to us. We also have third-party routers and firmware running in our data centers and in our devices, and we have third-party apps in our software stores. So this is a very important area for us. We've worked with a number of different vendors here at MSVR. You can read the list. Almost any company that makes software has received a vulnerability report from MSVR. One of the other goals we have for the program is to help make sure that we behave the way we would like others to behave. We want vulnerability disclosure to happen in a coordinated and private manner where parties are talking to each other. We want our reports to be interesting. We don't want bad bugs, we want good bugs. We want bugs with clear reproduction steps so that the vendor can take the report and immediately start working on a fix rather than having to spend time understanding the vulnerability. There are three main classes of people within Microsoft who report security vulnerabilities. The first and most important is individuals. We have people who work for us who are, probably like many of you, just interested in security, and they're finding security vulnerabilities for fun or to help secure the products that they use. We also have product teams who work with third-party products. For example, Windows has an SMB implementation, and that implementation works with the open source Samba implementation. So when we test our own SMB code, we have to interface with Samba. And in the process of doing that work, sometimes we find security vulnerabilities. Or when we test PDF functionality in Windows, we need to make sure it works with Adobe and with other PDF readers. In the process of doing that, we find security vulnerabilities and need to report them. When we do this, we often find many vulnerabilities at once. Microsoft conducts extensive test passes with lots of people, and that sometimes results in a large number of simultaneous bug reports. So one of the benefits of this program is to help the third party understand why we're reporting 20 bugs to them all at once. And then the last thing is we often just find individual bugs in the course of our normal testing. Windows tests thousands of applications with every change we make, and sometimes we find security vulnerabilities in them. We also have a legal aspect to this. Now, I'm not a lawyer. Don't quote me on this and don't sue me. But we have a policy that states that Microsoft employees must use coordinated vulnerability disclosure. You cannot use full disclosure if you are a Microsoft employee. And employees must notify MSVR of all vulnerabilities that they report. There's no obligation to report a vulnerability, and there's no obligation to use the MSVR program to report that vulnerability if it's found on your own time. But you do have to notify the program so we know what's happening in the security ecosystem. We don't want to interfere with relationships people already have. For example, we have network vendors, employees who sit at Microsoft. They have offices in our buildings. And so when we find vulnerabilities, we just walk over to their office and tell them. We don't do any kind of formal procedure. But this program is really designed for cases where we don't know how to get a bug fixed. So a few words about bug bounties, which I understand is a topic of interest here. We do allow our employees to collect bug bounties. So if you work for Microsoft and you find a security vulnerability on your own time, you can report it to a company that pays a bug bounty, or you can even report it to a vulnerability broker like the Zero Day Initiative, and you'll be eligible for a bounty. Now, in order to qualify for that, you need to have found the vulnerability without using company resources. So to accept money, it needs to be purely your own work, using your own computers and your own accounts. You are actually allowed to use company computers and company tools. We have some very good internal security tools to find security vulnerabilities, but you're not allowed to collect a bug bounty for those things since you use Microsoft's assets to do it. We also have our own bug bounty programs. We have an online services bug bounty where we pay varying amounts of money into the thousands of dollars for vulnerabilities in a specific set of online services. So it's not every service, but it is particularly focused around the Office 365 services. We have a large bounty for mitigation bypasses. That bounty can be as much as $50,000 for a novel mitigation bypass and $50,000 additional dollars for defensive techniques that address those bypasses. And the reason why we offer these bounties is to point researchers in a new direction. So we have a very good research community around Windows and Internet Explorer that we work very cooperatively with, but we've seen areas where the research community isn't as robust or isn't as interested. And so we offer bounties in those areas to have researchers work on problems that we think aren't getting the attention they deserve. And we found that bounty programs do attract attention. They get people working on areas that are novel to them, and that helps us make breakthroughs in areas that we think are interesting. So we've had great success with our bounty programs. We're very happy with them, and we're continually evaluating them for new options. So you can expect Microsoft to be a source of innovation in this area in the future. We encourage you all as well to participate in those, and the information is available on our website. So let me talk a little bit now about how this program actually works. The first step is once you've found a vulnerability, you report it to us. We have an internal web form to make it very easy to provide us all the information that you need, or you can just send us an email. The second step is to verify that this report is a high-quality report. Does it have enough information to understand the vulnerability? Is the vulnerability actually something serious? We don't want to waste people's time by reporting things that aren't actually security issues, so we verify that they meet a certain level of severity before we release it. We generally ask our finders to produce a proof of concept file, something that can be easily executed by the vendor to demonstrate the vulnerability. We like to include stack traces, and we like to include ideas for fixes. These are the kinds of things that make for a high-quality bug report, and that's what we want to give to a third party. And we will actually work with people to help them bring their research up to that level. We view this as a service we can provide for our researchers, a way to help them be better at their research. The next thing we do is make sure that we don't have this problem. So we often have a version of the software that the third party makes. So if there is a PDF bug, we need to make sure that that doesn't affect Microsoft's PDF readers. If there's a bug in the Chrome SSL stack, we need to make sure that Windows SSL stack doesn't have that bug. So we perform this check before we report bugs and fix anything that needs to be fixed on our side. Now, we don't wait to report the vulnerability until we have delivered our fix. We report the vulnerability immediately, but we coordinate with the third party so that everyone ships fixes simultaneously. This is actually the hardest step, reporting the vulnerability to the vendor, because many vendors do not publish contact information, and when they do publish contact information, it's often not specific to security. So we spend a lot of time trying to find the right person to talk to. Once we've found them, we want to make sure we exchange information securely, so we will request a PGP or SMIME key. And the typical response to that is, what is PGP? So we actually have a template that walks people through how to install PGP. Once we've solved that, we'll send them further information. Once we've reported the vulnerability, we work with the company while they fix it. And this is the longest portion of the process because some companies are not very fast. And we found that it doesn't correlate much with size. There are some small companies who work very quickly, and there are some large companies who work very slowly and also very quickly. So we stay in touch with them throughout. There's a conversation between that company and the finder about technical issues, about the severity of the vulnerability. We help mediate that conversation. Finally, the vendor will ship an update, we hope. We spend a lot of time helping them understand the need to provide credit to our researchers. Our researchers are not being paid for this vulnerability. They're only reporting it because they think it's the right thing to do, because it helps users. And the only thing that they will get in return is a credit, is public acknowledgement of their work. And so we strongly urge all people who make software to credit researchers who report vulnerabilities to them. And often there's a lack of understanding why it matters. Our program helps those vendors understand why giving a credit matters. And sometimes we've actually worked with them after the fact to credit our finders. We also will release our own advisories. We actually have two forms of this. We have a very long advisory that we use when we think a bug particularly needs attention. So we use this format to tell our users that there's a third-party bug that they need to get patched for. And we've generally not seen too many of these. We generally find that users update quickly. And So we don't use this too often. The other thing is our finders are allowed to release their own advisories or blog posts or other content once the vulnerability has been patched. We don't stop them from doing that. Here's an example of what that looks like. And these are all on our website. We also have a smaller page where we simply list individuals who have reported bugs. Most vulnerabilities are not severe enough for us to make a specific advisory to customers. So we just list the person's name, the bug, the severity, and the software that it was found in. Now we'll talk about a couple of specific vulnerabilities we've reported in this program. The first is in libav codec. This was MSVR 12-017. We started by fuzzing VLC with WMA files until we found some crashes. And that's actually fairly easy. You start your fuzzer, you run it, you get some crashes. The hard part is understanding whether those crashes are interesting or not. And so we first checked with the Bang Exploitable plugin. If you haven't heard of Bang Exploitable, it's a free plugin that Microsoft makes available for the debugger that will automatically analyze a crash and give you an indication of whether it constitutes a security vulnerability or not. So in this case, Bang Exploitable says that this is likely a security vulnerability. So this is worth spending time on to understand. And it also identifies the source as this libav codec plugin.dll, which means this is not actually a problem in VLC, but in the codec. So what we're going to do is diff the fuzzed file against the real file, the original file, and see what changed. So you probably can't see this on the screen, but what changed is a 01 to a 07. And what does that mean? This is hex binary, not usable. But we can throw it into this tool and find out. Microsoft has released a public tool called AuthViz. AuthViz is available on our website. It was released many years ago. And it parses files to help you understand how the file format applies to that particular file. It comes with definitions for Office files, but it's extensible so that other file types can be added. Here's what this looks like. When you load a file with AuthViz, it will show you exactly the file structure, the names of the field according to the file specification, and what those values are in that particular file. So in this case, if you had a telescope, you could see that this file says, I have to lean down to my own screen. You can see that the file says type-specific data, ASF audio media type, number of channels, and that's the field that's been changed. So now we know some things. We figured out that ASF is a container format for WMA files, and we can look up that particular field in the ASF specification. And when we do that, we see this is a 16-bit value. It's a member of the wave format X structure, and it's supposed to be the number of audio channels for this content. Well, it turns out that the number of audio channels is never supposed to be 7. That causes an error. And in fact, changing the value to anything from 3 to 8 just by manually editing the file causes a crash. We also found some interesting behavior if you changed it to 9 that we didn't explore further. And so we can track this crash and see what happens. And what we notice is 2 instructions, pop EBX, and call a longer instruction I won't read. And for those who know assembly hacking, this is an exploitable condition. So we can tell that we're going to be able to exploit this vulnerability now. And we're confident at this point that this is an exploitable bug. And we've done the research so that when we report the vulnerability, we can tell the vendor why this is a problem and why they need to fix it. So at this point, we wrote up what we found, and we sent it over to VLC to pass along to the codec company. And the MSVR, so all that came before this was done by Jeremy Brown. Once he packaged it up, he handed it off to MSVR, and he went back to his day job. And MSVR found the right people to talk to at VLC and worked with them to set a release date for the update and ensure that they met that release date. We also answered some basic questions they had and went back to Jeremy as they had technical questions. This was ultimately patched in May of 2012, and we released our advisory a couple of months later. A second case study is a vulnerability we reported in VMware. This was MSVR 13-002. The first thing we started with our analysis of VMware was the file types that it processes. And in particular, we focused on the OVF file type. This is the Open Virtual Machine format. It is essentially an XML-based format for describing the metadata of virtual machines. The nice thing about XML, it's a very nice fuzzing target. So before we started that, we actually analyzed the process flow. It turns out that VMware doesn't directly load OVF files. It uses a separate utility to do that. We researched some information about that utility. It's a standalone exe. And what we eventually found was if you pass into that tool an XML format that includes %p, format strings that are expected to be pointing to pointers, well, this was not handled well. In this dialog, you can see that it is displaying the contents of random parts of memory. So this is an indication, again, of likely an exploitable vulnerability. So as we researched further, we reported this to them. In this case, we have an outstanding relationship with the VMware security team. A number of them actually used to work for Microsoft. And so we reported this to them relatively early because we knew that they would be able to take it the rest of the way and fully understand the vulnerability. So we gave it to them quickly, and they issued a security update. We've learned some things throughout this process. And one of the things we've learned is that vendors range very greatly in their capacity. I mentioned this earlier. We have worked with some very large companies who moved very, very quickly and issued security updates within just a couple of days. We've also worked with some very large companies who worked very, very slowly. In many cases, we've had bugs outstanding for multiple years without a fix. And this is not a case where the vendor didn't respond to Microsoft. This is a case where they are actively working on it and providing status updates, but they're just having trouble fixing the vulnerability. Microsoft does not believe that it's ever the right thing to release a vulnerability to the public. We just think that a cooperative relationship is always the right way to go. We have struggled to come up with ways to incentivize vendors to work faster, but we do have some leverage. Many companies have large contracts with Microsoft, have partnerships with Microsoft. And so when we have trouble with the vendor, we're often able to work with them through other business channels to help them understand why it's important to release an update quickly. What we've generally found with larger vendors is that they want to do the right thing, but they don't have the technical skills to do it. And sometimes that's a long process where we have to start at their executive level of helping them understand why security is important. And that's one of the reasons why my program exists. On the other hand, we've had some very bad experiences with small companies. You normally think of them as agile, as you talk to the developer directly. But many of these companies have no security skill and no time to learn security skill. At a large company, we can always assume that they can afford to hire a security developer, but at a company that employs 2 people, they can't do that. So that's, in some cases, we've had to teach them all about security ourselves. Another thing that we've learned is there's a variety of behaviors that researchers display, and some people view their responsibility as only to generate a crash dump. Well, we don't think that's a good way to interact with a third party. It's not very nice to run a fuzzer and send 100 fuzzed files to a third party when most of those files are not demonstrating a security issue. You're either going to cause the third party to spend a lot of unnecessary time examining those files, or you're going to cause the third party to not look at them because they decide that you are not helping them. And if there is a security issue in one of those files, they won't look at it. So we believe it's very important to examine your files before you report them and only report really interesting things. And we ask that when you report vulnerabilities to us, that you do the same. The other problem we've had is there are people who are so passionate about security that they think every little problem is the biggest problem in the world. And we want to help those people understand that there is a range of problems. And this is not to say that that all security problems are not problems, but they have different levels of severities. The world will not end tomorrow if a cross-site scripting bug isn't patched within 24 hours. It should be, but that's a very big difference compared to a remote code execution flaw in a widely used piece of software that's likely to be used in a true attack campaign, or that is actively being used in an attack campaign. One of the other things we've learned through this program is this is a great benefit for employees. Our researchers love this program. They love the fact that they can find some issue and report it to Microsoft, report it to MSVR, and then not worry about it anymore. They can go back to doing the research that they love. And it's also important for people who don't know anything about security. Most of our developers know how to write secure code, but they don't know anything about how to manage a vulnerability. And so once they've found something, they need help. And we are that help. And they value this a lot. So we've had great success in our employee relationships. The other thing about this program is it's extremely cheap. We actually don't have a full-time person running this program. I manage the program among a number of other programs. The person who does most of the work for this program has other jobs as well. So it is very easy to do something very, very impactful. It does not take a lot of time. So I would encourage any company that has a large enough employee base to find vulnerabilities to run a program like this. As I mentioned, it's something that employees really value because it gives them something where they can follow a standardized process without needing to know all of the details. To be honest, we found that the number of security researchers who are doing this as a hobby is a very small percentage of all Microsoft employees. Much less than 1% of all Microsoft employees participate in this program. But the people who are participating in this program are extremely passionate about security, and having this program makes them feel much better about working for our company. These are people who we love having work for us. They're very talented individuals. And so when you go back to your own companies, think about those few people who will be very, very excited to have a program like this. The last thing is, we are not the only company whose product depends on others. As we've heard throughout these talks, and as I think many of you know, we are all interdependent now. Almost every product includes lots of third-party code. Think about shell shock and about Heartbleed and about these other issues. We all have other people's code in our software. We all interconnect with services and devices from across the industry. And if we don't have a good way to work together, we're going to cause problems for each other. And we've seen that when issues became public prematurely and some websites were exploited. And it wasn't because anybody wanted to embarrass someone. It wasn't because someone wanted to cause problems. It was just a simple failure to communicate. And having a program in place with a defined process helps prevent those mistakes. There are some things that we found as a finder that made us think about how we behave as a vendor. And that makes us ask you who have software to do some things to help us help you. So please publish a clearly identified point of contact for security vulnerabilities. Let us know where we should send this information. We spend far too much time talking with support staff and explaining to them why we don't have a support contract, why we don't have an official license to the software, but we are trying to help you. Give us something like security@yourcompany.com, secure@yourcompany.com, where it will be very easy to reach you. Publish an encryption key. This is important for two reasons. It's important for us to be able to send you information quickly. Consider that there may be a public vulnerability or exploit in your software that we need to tell you about. That needs to happen quickly, and if you have a public key, we can do that. The second thing to consider is, what if some problem happens in your company's website or in your software that makes people distrust your communications? This has not happened to us in real life, but in exercises, we've simulated possible breaches of our website. Well, how do you get the message to your customers about the truth and how to recover if your website can't be trusted? You can't post anything on your website because they won't trust it. But if you have a public encryption key, they will know that anything signed with that key is likely trustworthy, as long as you've established that the key itself is secured. It's not a 100% solution. Work with your support staff to understand vulnerabilities. We have a number of times worked with support staff who acknowledged that we were reporting a security vulnerability, but said we would have to pay for a hotfix to get it fixed. We ourselves work with our own support staff to understand that when a vulnerability is reported, that should be immediately forwarded to a security professional rather than handled through customer support channels, because you can't afford to have a vulnerability become public or be exploited or even simply not be fixed because your support staff doesn't understand the impact. And these are issues that most companies never think about. And so the reason we're here talking is so that you go back and think about these things. When you work with us, we'd like to see clear communication. This seems like something basic, but more often than not, we do not have an effective communication with the people we work with. Write back to us when we send you an initial email. Even if it's an automatic reply, at least we know we've gotten a live email account. Tell us whether you've successfully reproduced the issue. Sometimes we're wrong. Sometimes we report a bug that does not reproduce. Sometimes we report a bug that's contingent on a very specific configuration that we have but no one else does. So please tell us if we found something real or not. We don't want to waste your time if we found something that isn't a problem. Please tell us when you're going to ship the update. We have had a number of times where we pinged someone month after month after month, and 6 months after we start, they say, we fixed that 4 months ago. So please don't do that to us. We would like more advanced behavior. Credit us and ask us how we want to be credited. We generally credit Microsoft Vulnerability Research and our finders, but some people don't want to be credited. Some people would like to be credited under a pseudonym. And so please ask. The other thing, which is a whole topic of its own, is variant investigation. And by this, I mean check for related bugs. When we report something to you, we found one issue. Almost always, there are other bugs in that code. And a problem we've seen in the industry is that people fix the one vulnerability that was reported to them, and then they stop looking. They go home and they call it good. Well, the programmer who wrote that code made a mistake. They probably made other mistakes. Even if they are a very, very good programmer, once you release a security update, it's going to be reverse engineered. And people are going to look in the surrounding code. So we internally look at a number of different related vulnerabilities. We look for things that are in the same part of the file format. They may be handled in a completely different code path, but there will be bugs that are found in related code, in related parts of the file format. There will be bugs that will be found in similar code paths. Often we found that code is copy and pasted. So do a simple find for that same buggy line of code, and you will probably find other bugs. Do a check for the same research method. We once saw a researcher who submitted 3 bug reports to us, all using the same exact file, and they were doing sequential file fuzzing. They took an FF byte, and they moved it down the file 1 byte at a time. And by the time they gotten halfway through the file, they'd found 3 exploitable vulnerabilities, and they sent them to us. And so we figured he was going to continue moving that byte down the file. And so we did that ourselves and found several additional vulnerabilities. So take what the researcher has done and do it yourself. The other thing to raise there is Microsoft has a significant amount of security resources. And we tend to find all the bugs that we think to look for. And in general, developers will find the bugs that they look for. What external research provides for you is an idea of what you are not looking for. It tells you the things that you haven't thought of. And this is why security research is so valuable to Microsoft. We hire lots of security testers, and they find lots of vulnerabilities, but they all work for us. They all think like us. They work with the people who work with us. And so they look in the places that Microsoft knows to look. The security community looks in the places that Microsoft doesn't know to look. And every time a vulnerability is reported to us, we examine that code, and we realize often that there are many vulnerabilities in that code. It's a piece of code we didn't know about, or it's a testing technique we didn't know about, or it's a piece of code where the person who tested it did a bad job. That does happen. So we very, very much value the participation of the community because it helps us improve. And when we find a mistake that we've made, we can solve that mistake across all of our products. We can take that information across all of our products. And what we want to see is other people doing the same thing. When we report a vulnerability, we want to see not just that vulnerability fixed, but 50 or 100 or 1,000 additional vulnerabilities fixed because our vulnerability showed that company where to look for vulnerabilities. That's what we want to see from the industry. And we have a long way to go as an industry. There are thousands of vulnerabilities in essentially every piece of software. We don't fix those vulnerabilities one at a time. We fix them hundreds or thousands at a time. That's the only way we can make a measurable impact on the number of vulnerabilities in our software. And it's expensive. It's hard to do. It's very hard to have the conversation with your manager and their manager and the vice president and the president about how much money this will cost. But the cost of a breach of your company, the cost of a breach at a customer site is far, far greater. Far, far greater. This is a lesson Microsoft has learned the hard way. You probably have heard of Slammer and Blaster and major, major customer problems caused by security flaws in our software. That was a long time ago. We've come a long way. We're still not perfect, but we have some things we've learned that we want others to learn too. We want everyone to be secure, even our competitors. And if there's one thing you take away, it's when someone reports a vulnerability to you, be thorough. Use it as an opportunity. Use it as a chance to fix all of the bugs in a whole area of code and never have that problem again. And this is what we want to see. Oh, and also, please do it quickly. We understand the complexities of engineering large pieces of software. We understand that some vulnerabilities take a long time to fix. We also understand that some vulnerabilities don't take a long time to fix. We understand that there are some things that should be done quickly. And we are in a good position when we report vulnerabilities to help you understand the right amount of time to spend. So be thorough, but be quick, and be diligent. These are issues that we're not going to solve tomorrow, but by working together, we can make all of our customers better. We can make all of ourselves more secure. And eventually, in 20 or 50 or 100 years, we should not be talking about code vulnerabilities anymore. This is fundamentally, every vulnerability is a programming error. And one of the goals of this program is over time, a very long time, not 10 years, 20, 50 years, to reduce the number of vulnerabilities in all software. And we encourage you to be diligent in that work. We hope that this talk is a resource you can use when you go to your own companies to say Microsoft does this and so we should too. I'm happy to provide a personal intervention with anyone who needs to hear from Microsoft that this is something we do. This is also documented on our website. We encourage everyone to have programs like this and to respond well to vulnerability reports. So, thank you, and I can take questions now.
So thank you for your presentation. How do you handle the timing of release of the vulnerability information? For example, CERT organization. Do you think we should work closely together with them, or is it better to not to align with them at all?
Good question, thank you. The question is, when it comes to the timing of releasing vulnerability information, how do we manage that, and do we work with CERT organizations? And the answer is, we work with the vendor to understand their preferred timing, and if their preferred timing is not good for their customers, we work to persuade them to change that timing. That applies to their information, their publication, and our publication. So if they ask us not to publish before a certain date, we will not publish before that date. However, we will work with them to improve that date if the date is not good. With regards to the CERT organizations, we will work with CERTs depending on the country and that CERT's role. Some countries, the CERT is very involved. In other countries, the CERT is not very involved. And so we will work with the CERT where it's helpful. We have relationships with essentially all of the CERTs, and we will work with them where it is helpful.